So we're starting off with a nice and simple equation here. Just 2 steps, nothing crazy, no distributing, no fraction busting, nothing like that. All we want to do here, again, the goal for all of these is to get x all by itself. So we have to start peeling away the layers around that variable until it's all that we have left. Let's start with this outer layer here, this plus 10. And we want to get rid of that by bringing it over to the right-hand side. Well, we can't just take this term and drag it over there. We have to do the inverse of that term, which for addition, the inverse would be subtraction. And again, we're not just going to subtract 10 from the left. We have to do it to the right. Remember, think of an equation like a scale. If you take 10 away from the left, oh, now the scale's out of balance. You got to take 10 away from both sides so the scale gets balanced again, right? We can cancel those 10s out because they produce a 0. We're left with 6x on the left and 18 on the right. Now we take a look at x and we say, all right, currently what we're doing is we're multiplying x by 6. So we're going to do the opposite of multiplication, which is what, everybody? Division. We're going to divide both sides by 6. 6 over 6 cancels out to just 1. Leaving us with x equals, and then 18 over 6 gives us 3, right? Box it up. That's all you need to do for number 1. Take a look at that work. It's not that much work to even show. I know some of you are like, oh, well, I could do this problem in my head. That's great. I'm proud of you. I still need to see the work, though, okay? Because I can't differentiate who knows it in their head and who just guessed or who just looked at their neighbor's paper. Once all these tests are in my hand, I don't look at the names. I cover up the names and I grade them all unbiased, okay? So, let's move on to 1B. This is why we talked about the warm-up that we did today. Because we're going to have to identify here 4 different things. We have to identify all of our terms in general. Then we have to break that up into like terms. We have to identify our coefficients and then our constants. So let's start with terms. What are the 4 terms we have in this equation? Azalea, you want to help me out? What do we got? Negative 4x. There's our first one right there in front. Positive 5. That one comes next. X. It's right there next to 5. And there we go. Negative 7. Now some of you may be like, I thought that was a minus 7. This is why I said at the beginning of the year, stop thinking about addition and subtraction as 2 separate things. They are the same thing. Subtraction is just the addition of a negative number. You guys see what I mean? So if we have a minus 7, we could easily rewrite this as plus negative 7. Right? Because a plus next to a minus forms a minus. So everything we're learning is connected. We got to start trying to see these patterns, or at least looking for these patterns. If we have a minus 7, the term itself is negative 7. That's important. Now, what are our like terms here? We got 2 sets of like terms. What's the first set? Azalea, go ahead.
The first set is negative 4x.
Perfect. And what's that term's like term? X. Exactly. Same variable, same power. Those are like terms. What's our second set of like terms going to be, though? Mason? Exactly. 5 and negative 7. 5 and negative 7. They don't have the same variable because they don't have a variable at all, but that's what makes them like terms. Remember, like terms are just 2 terms we can combine or add together. 5 and negative 7 can be added together, so they're like terms. What's our 2 coefficients? Andy? Negative 4, and there's the tricky one, 1. Our second coefficient is 1. Even though this x is all by itself, what it really says is 1x. So when we're listing our coefficients, we cannot leave that 1 off. We have to include that in there. And what are the 2 constants that we have in this equation? Where's the numbers without a variable, Jordan?
5 and 7.
5 and, be careful, negative 7. 5 and negative 7. All right? Now, if you get all of this right, you organize all the numbers correctly, and you accidentally put a positive 7, I probably wouldn't take any points off because I know that you know what you're trying to do, if that makes sense. But this is something we got to start remembering. If we see a minus 7, we got to think of that as a negative 7, not just minus positive 7, okay? Any questions about these identifications here? Okay. I know some of you may be like, well, I already know how to do this whole thing, so this isn't really important for me. You may hear something that you didn't know, right? It's impossible to know everything that you don't know, so it's always helpful to just pay attention. So this one confused a couple people because we've never seen something like this before. Basically, and that's my fault, I haven't shown you guys anything like this. This left-hand side is an equation being solved, right? Just like how we do it. We have our full equation here. That's what's given to us. And then this first step here, something happens to our equation. We see these parentheses disappear. We must have done something, right? And then the next step would be us combining these like terms, this negative 6 and negative 3. So the left-hand side is what's happening in the equation, and the right-hand side is an explanation of that in words. So what happened here from our given equation to this second step? What did we do?
Distributed property.
We distributed this 3. See how the 3 is on the outside of the parentheses? We multiplied 3 by x. We multiplied 3 by negative 2. And we got 3x minus 6. From this first line to this second line, what we did was use the distributive property. Okay? This word bank, if you've never seen a word bank before, this gives you the 4 possible answer choices. You've got 4 blank boxes to put an answer. So each of those choices is going to go in one box. We can cross out distributive property now. So then we move forward. Like I said, we combined negative 6 and negative 3. We got negative 9. That was combining like terms. And then we can see here, if we split this equal sign, that we seem to be subtracting x from both sides. That's our inverse operation, moving our variable term over to the left. So what can we say is happening here in this step? Are we doing addition, subtraction, or division? Subtraction, right? It's very clear. We've got 2 minus signs there. We're doing subtraction. We combine those like terms again, and now we can see that we're adding 9 to both sides. What can we call that step? Addition, perfect. We get 2x equals 14. And then we divide both sides by 2, so obviously that one's going to be division. So I know we haven't necessarily seen anything that looks like this just yet. We probably won't in this class. But we're just describing each step, right? It's more of a vocabulary thing than anything. There was a couple questions about this on the survey as well. Does that kind of clear things up on number 2? Maybe? Yeah, okay. I see thumbs up. That's good. All right, let's go into the word problems before we jump to the back with all those fun equations. So Dan and Sydney here. They're getting high-speed internet access. Dan's provider's charging $32 for installation and $5 per month. I'm going to go ahead and highlight that in yellow real quick. Okay. And then we've got Sydney's provider. Sydney's provider's charging $8 installation, way cheaper, but $9 per month. A little bit more expensive on the monthly side. How many months? I'm going to box that up. How many months? This tells us right away our answer is going to be blank months. Okay? So down here for our answer, I'm going to go ahead and write in months right away, right here. Just so I don't forget that I need to have units on my answer. How many months until they pay the same amount? Again, same amount. That's always what we're doing with these problems. So So let's organize our information. We'll go for Dan, and then we'll go Sydney. We'll talk about let x equals in a second. Dan's numbers are 32 and 5. Sydney's numbers are 8 and 9. Now this is where things get tricky. Sydney's numbers are very close together, the 9 and the 8, right? But if we get them in the wrong spot, we create a very different equation. Which of Dan's numbers is our unit rate? 32 or 5? 5? Okay, Theo, why do you say 5 is our unit rate?
Because it says $5 per month.
Okay, what does that mean?
It means every month it costs $5.
Exactly. So the $5 payment is repeating every single month. That's how we know right away $5 per month is our unit rate, which means 32 must be our initial value or our starting point. Right? You start out paying $32 just to get it installed, and then you're paying $5 a month after that. So we can write the equation 5x plus 32. Right? mx plus b. 8 and 9 for Sydney's internet provider. Which of those is our unit rate? 9 is going to be our unit rate. Once again, we take a look back at the question. $9 per month. Whenever we see per, we know that we're dealing with the unit rate. Or if we see the word each. $9 each month or $9 per month, that tells you 9 is our M. And that makes 8 our what?
Initial value.
Our initial value or our B value, right? So we can set up the equation 9x plus 8. Double check right now and make sure you didn't accidentally write 8x plus 9. If you wrote 8x plus 9, that's understandable. It's a common mistake. But you're going to get a very different answer at the end of it if you keep it. So make sure you've got 9x plus 8. And we're going to set those two equations equal to each other because we want to know how many months it'll take for them to have the same amount. Same amount. So we want the amounts to be equal. Now, we want to also define what x represents in this problem. That's what this means right here. Let x equal blank. I saw some people thinking that's where your answer went. Again, this is my fault for not mentioning this prior. But let x equals is looking for a description, not a number, a description of what x represents. Yeah, Noah? Oh, yeah. So what can we say that x represents in this equation, Noah?
Months.
That's right. The number of months. Let x equal the number of months. And that makes sense because we had already identified that our x at the very end is going to be in months. Right? So we know that x is going to represent months. Y represents the total amount that they've paid. That's why we're able to set these equations equal to each other. Any questions on this setup so far? Jordan, were you going to help me out with the next part?
Yeah.
Okay, just give me 1 sec. Is there any questions on the setup of this problem? Because once we get to the actual equation, the solving is very simple, right? It's just inverse operations. But setting it up and setting it up correctly, that's the hard part. Jordan, what are we going to do from here?
Subtract 8 from 32. Oh, wait, 9 from 5.
Yeah, let's go ahead. Let's start with our variable term. Let's subtract 9x from both sides. Now let me ask you this. Why am I subtracting 9x from both sides? How come I'm not adding 9x to both sides? Jordan?
Because it's a positive 9x.
This 9x is a positive, you're saying?
Because inverse operations.
Right. So you're saying that this 9x is positive?
Yes.
But I don't see a plus sign in front. How do you know that it's positive?
There's no negative.
Exactly. That's the reason. We know it's positive because there's literally no negative sign. It's that simple, right? We can talk about, if there's a number without a plus sign, there's really an invisible plus sign. But, that's just a different reason. The actual reason is there's no minus sign there. Just like with 5x. There's no minus sign there. We have to assume that it's positive. So the inverse of a positive number is always a negative number. It's easier to see that we're subtracting if we have something like 8, where we see that plus sign, our brain knows to flip it into a minus sign. But when we don't see that plus sign, I want you to know that it's there. This is a positive term because it's very clearly not a negative term. Does that make sense to everybody? Does that make a little bit of sense at least? Okay. Thank you for that, Jordan. That was great. 9x's cancel out. 5x minus 9x gives us what? Negative 4x. Thank you. We've brought our variable terms over to the left. What are we now going to bring over to the right? Andy? Yeah, exactly. Our constant term, which is 32. We see that we're adding 32. We'll do the opposite, which is subtracting 32. I'm going to move this over to the left a little bit. We're left with negative 4x equals negative 24. Negative 4x equals negative 24. What's our last step going to be to do? Divide both sides. Thank you, Alexa. We divide both sides by negative 4. Those cancel to 1. Negative over a negative, luckily, those cancel out. And what's 24 divided by 4? Positive 6. So our answer is going to be x is equal to 6 months. Didn't even have to remember to write our units on the end because we did that at the very beginning of the problem. I saw a whole lot of x equals 6's and not a whole lot of x equals 6 months. You need to include the units or I will actually take a point off for that. You must include the units when you're solving a word problem. Okay? How are we feeling about number 3? Quick show of thumbs. These word problems are usually always the last lesson of the unit, which means it's the freshest in our minds. Could be a good thing or it could be a bad thing. So it helps to see where you guys are at. Yes? Yeah, no, go ahead. Oh, you're gonna help me out with this one, you said? Oh, okay, my bad. All right, let's jump over to number 4. Now, number 4 is a little bit more confusing than number 3 because of the way that our data, go ahead, Jordan, because of the way that our data is arranged here, right? It's not listed out in a paragraph like we're used to seeing. The information's listed out in a table. So we really have to understand what's going on in this table if we want to set this up correctly. We're taking a look at 2 different shuttle services here, and we're going to find the number of miles for which the total cost is the same. So we're looking, find the number of miles. My answer is going to be X number of miles. Right away we can do that. We can write our units down before we even organize our numbers. So if we know our answer is X equals blank miles, what can we let X represent here? The number of miles. Exactly. Number of miles. So let's take a look here. Basically, I want you guys to be careful you don't get confused horizontally as opposed to vertically. I'll show you what I mean by that. Easy Ride is the first company we're talking about. Easy Ride's numbers, or like I've been saying, the numbers associated with Easy Ride are 30 and 4. Okay? So 30 and 4 need to be on one side of this equation. Which of these is our unit rate? 30 or 4? 4. How do you know that 4 is our unit rate?
Because it's charged per mile.
Exactly. Per is right there. Whenever we see per, we know that we have our unit rate. And the pickup charge, that's just a one-time fee that, of course, you only have to pay once. Best Ride is our second company. Actually, you know what? Let's set up Easy Ride's equation. What's Easy Ride's equation going to look like?
4x plus 30.
Thank you, Azalea. 4x plus 30. And then we got Best Ride. The numbers associated with Best Ride are 14 and 6. Again, which of these numbers is our unit rate? Is it going to be 14 or is it going to be 6? 6? Why do you say 6, Theo?
Because it's repeating.
It's repeating. It's $6 per mile driven. Every single mile that you drive, you get charged that $6. So we can write the equation 6x. I'm sorry, I accidentally wrote m here for 4. 4 is our b value. 14 is our m. Wait, I'm sorry. I'm all messed up now. See? This is what I warned you guys to be careful of, and I just fell right into it. I got mixed up between the vertical and the horizontal here. Yeah, sure. Pickup charge. Those are our B's. Charge per mile. Those are our M's right there. So again, if I can make that mistake, you guys definitely can too. Try and be hyper aware of that, because you are going to see a table representation like this tomorrow. So our easy ride equation was 4x plus 30. Our best ride equation is going to be 6x plus 14. Set them equal to each other. Split it down the middle. Let's go ahead and solve. Before we do, are there any questions about the way that we set this equation up? Okay, good. Because like I've been saying, setting it up is the hard part. Now all we're going to do is bring 6x over to the left, giving us negative 2x plus 30 equals 14. We're going to subtract 30 from both sides to get negative 2x equals negative 16. And then we divide both sides by what?
2.
Negative 2. Negative 16 over negative 2. The negatives cancel out. And what's 16 divided by 2? 8 miles.
8 miles.
Again, I saw a whole lot of 8s, not a whole lot of 8 miles. Okay, we got to make sure we're including our units on the end. Questions at all on number 4? Okay. Now for the fun part. The backside. We got 6 equations here. They all look fairly frightening at first glance. Like I mentioned earlier, worksheet 40, I think it was worksheet 40, had the equations on the front and back that look like this. These are the types of equations that you can expect to see on the test tomorrow. The only real quote-unquote easy equation or simple equation is that number 1 right there. Okay? So, we've been building our toolkits of information all unit long, figuring out what possible procedures we can use to solve this equation. In fact, we even have a solving order. Let me grab that. Here is our solving order that we took notes on last week, just as a refresher. And I'm going to go ahead, I'm going to get a sticky note here, and I'm going to shorten this. First, we're going to distribute. Second thing is fractions. 3 is combine like terms. 4th is inverse operations. And then we got to state how many solutions we have, which we'll get to. So these are the 4 steps. We have to complete these steps in this order. Think about PEMDAS, right? Everything needs to be done in order. And I'll leave that right there. So we take a look at number 5 and we ask ourselves, is there anything we need to distribute? What do you guys think? Is there anything we need to distribute in number 5? Is everybody still with me here? All right.